In this example, we're going to apply some of the techniques developed for XPS imaging to Raman data. In this Raman data set, we've got spectra that have been measured at different positions on a sample. And the characteristic of this Raman data is that there's a rising background. And because of this rising background, most of the images have the same background component, which dominates any PCA type calculations. So we're going to use differentiation to try and improve this situation. And we can use an option on the spectrum processing dialog window, differentiate. And this is Savitsky-Golay differentiation. And because it's an imaging data set that contains multiple spectra at each pixel, we must apply this to all of the corresponding variables. Now, before we do the differentiation, we're going to use some noise enhancement simply based on the spectra themselves. And we'll do this, we'll use 40 scans. That means we're going to use a 40-dimensional eigenvector calculation. We're going to reproduce the data using 20 abstract factors, so we won't expect to get rid of all the noise, but we'll get enough so that when we do the differentiation, the spectra then produce the characteristic pulse peak shapes rather than the Gaussian peak shapes without too much noise. So you can see here each of the corresponding variables have been differentiated. And once we've got the data in this state, we can then reconstruct the image data set based on the differentiated spectra. And because the differentiation now favors a sharp peak rather than a slowly varying background, each one of these images now have the characteristic shape of what you'd see in noise. So when we do the PCA calculation, you end up with abstract images that have partitioned the information based on the chemical information rather than the background information. So if you look at the original data set and you calculate the abstract factors for the original data set, you can see that the first one has the characteristic of the background signal, the second one and the third mostly background, and it's not until you get further down in the sequence of abstract factors you start seeing the chemical information. So by differentiating, what we've done is we've promoted the chemical information to the top of the list. And once you've got this chemical imaging, you can then use false color maps, extract spectra, and do the vector calculations that we've done with the XPS datasets before.